Hello everyone, Darren from DrayTek Australia and New Zealand. As part of maintaining your network, you may sometimes encounter issues that affect network stability or connectivity, or you might just be having trouble getting something to work properly. Troubleshooting can often require a combination of using the system maintenance and diagnostic functions in the router, as well as Telnet to obtain certain Syslogs. In this webinar, I'll go over some troubleshooting tips which should help you to resolve some common problems. Listed here are some of the more common issues we've come across. We'll start with showing you how to capture router Syslogs, as this is often required for more complex issues. Then we'll take a look at these other topics. Syslog stands for System Logging and is basically a record of everything that happened in the router. It includes information like timestamps, that is when something happened, as well as IP addresses and MAC addresses of the devices that sent or received the data, what type of data it was, and more. It's extremely useful information when it comes to troubleshooting. There's 4 different methods you can use to capture Syslogs from DrayTek routers. The first is to use DrayTek's Syslog utility tool. This one's a free download from the download page on our website, which you'll find under the support heading at the top of the page. We'll use a Vigor 2927 router as an example. So first up, you want to make sure the system time and date is correct. If it isn't, go to System Maintenance, Time and Date to set it. Then go to the Syslog Mail Alert menu and enable Syslog. Then select the Syslog server. This is the IP address of the PC that will be running the Syslog utility. If you're not sure what that is, the easiest way to find out is to open a command prompt on the PC and type ipconfig. Here we can see it is 192.168.1.10. Then select which logs you want to see. If you don't want to see them all, just select the ones you want. If you haven't done so already, download the Syslog utility from our website, then run the .exe file. And here it is ready to capture the Syslog. Sometimes firewalls can block it, so if you don't see anything happening, you can try disabling that, at least temporarily. And away it goes now. Up the top here, you can select Syslogs by type, whether firewall, VPN, user access, connection, interface, IP PBX, wireless, and others. Some of these have additional options like the interface tab here, which has WAN, LAN, and DSL debug logs, and you can also see a traffic graph. To save the log, just click on the save icon up the top. Then you have options to save the current log to a file, record to a file in real time, or record to multiple files. Select which one you want, give the file a name, and over to the right, if you click on those 3 dots, you can browse to where you want to save the file, then click OK. Then open the folder where you saved it to, and you can open it to view it. The second method is to save the Syslog to an attached USB drive. This doesn't require the Syslog utility running on a PC or any PC to be involved in the process. Instead, you just plug a USB drive into one of the USB ports on the router. Then go to System Maintenance, Syslog Mail Alert. Enable it, then select the USB disk option. Keep in mind that the USB drive needs to be formatted to use the FAT32 file system, and it needs to be smaller than 16 GB. It's a good idea to select Overwrite Oldest Logs here as well, so it won't stop if the drive gets full. Then select which logs you want to save, then click OK. You can then view the logs under USB Application File Explorer. Just click on the file to download it to your PC. The third method is to view the logs using the Syslog Explorer option in the router. You'll find it in the Diagnostic section. Just enable Web Syslog, then select which logs you want to view, and the display mode, whether always record the new event or stop recording when full. You can view the logs here, or you can click the Export button to download the log to your PC if you want to save it. The downside with this method is it's restricted to 1000 lines. For larger log files, it's recommended to use the USB disk option. The final method is to use Telnet commands. Just keep in mind that it's only usually used under supervision from DrayTek, since it requires a special firmware which contains a script which will raise a log entry in the event of an error. It also can run for hours and collect a huge amount of data. The script filters out events that aren't related to the issue being monitored. First, we'll need to create a directory where we want the logs to save to. Using Windows Explorer, create a folder in C drive and call it local data. You can use Telnet either from a command prompt or using the router CLI. We'll use a command prompt in this demo. Now we need to make sure we're in the folder we created, so type cd c:\local data and enter. Then start a Telnet session by typing telnet, then enter. To capture the log to a file, we have to give it a name. To do that, type set log file capture.txt. Then to access the router, type open 192.168.1.1 or whatever the router's IP address is. You'll be prompted for the admin username and password. Then to launch the log capture mode, type sys admin DrayTek, then sys con2tel enable. It tells you what to do from there. Hit Ctrl S to start debug mode, spacebar to stop it, Ctrl C to exit, and Ctrl D to exit Telnet. Then in the local data folder we created, we'll find a file called capture.txt, which can open in Notepad to view the log. Another option is Wireshark. When router Syslogs don't provide enough information, we need to capture WAN and LAN data packets to see exactly what's happening. This is helpful for support engineers to analyse various issues. Data packets traversing WAN or LAN ports can be captured by using a packet sniffer tool installed on a PC. One such tool is Wireshark, which is used in conjunction with the port mirror function of the router. Port mirroring of the WAN interfaces will affect the router's performance, so always disable it when not required. Port mirroring of the LAN ports will not affect performance. So to capture the data packets, we need a PC running Wireshark or some other packet sniffer tool and the port mirroring function to be enabled in the router or switch. To enable the port mirror function in the router, go to LAN port mirror, then select the mirror port, which will be the port that the PC running Wireshark will be connected to. Then the LAN or WAN port that you want to capture packets from. More details are in the two knowledge base articles down the bottom here. I'll include links to them below. Now that we know how to capture Syslogs, let's take a look at some issues you might encounter. The first one we'll look at is unexpected router reboots. Routers usually restart to correct an error condition detected. To check if the router has restarted, just go to the Online Status Physical Connection menu or the dashboard in the router and view the router uptime. An unusually low uptime indicates the router has restarted recently. There are four main reasons that cause a router to reboot. The first one is that the reboot happened due to a scheduled maintenance task, such as a firmware upgrade being done, a configuration change that required a reboot to save the settings, or the reboot command was issued. Another cause of the router reboot is when a faulty USB device is attached to the router. This can put the port into an error state and cause the router to crash. The third reason is a faulty power adapter, which provided reduced power to the router and made it unstable. The fourth reason is from a firmware bug. To check if the crash occurred due to a firmware bug, go to the router CLI using Telnet or the web console. Then run the command sysverdbg. The information displayed is the system information, including the firmware version. If the crash occurred due to a firmware bug, you'll see the line firmware exception debug info, which you can see in the middle of this screenshot at the dotted line. Below that, you'll see which CPU registers were used and which processes were running before the router crashed. You can save a copy of this output and forward it to us so we can send it to DrayTek R&D for analysis and a fix via updated firmware. To clear the debug log, run the command sysverdbg reset. If the debug log is empty after a router crash, it indicates that the reboot was due to other causes, such as a planned reboot, configuration change, or a loss of power. Later model routers and firmware have an option to send the debug log via mail alert, which you can see on the right here. In the Vigor 3910 and 2962 routers on the left, the debug logs are available for download. The next troubleshooting tip is what to do when you forget the router admin password. This can sometimes happen when a network administrator leaves an organisation and doesn't pass the information to the new administrator. If you're lucky, you might have a configuration backup. However, since the configuration file is encrypted, it's impossible to recover the admin password from the file. Luckily, there are two ways to recover it. One way is to restore the backup configuration file without the password. I'll explain more about this option shortly. The other method is to reset it using Vigor ACS. If all else fails and you don't have a configuration backup, the last resort is to reset the device to factory default settings by pressing the factory reset button for at least 5 seconds, then reconfigure manually. Hopefully you'll at least have some documentation on what settings were used to help you set it all up again. Okay, so how to restore the router configuration without the admin password. For this method to work, the configuration file must be one created from the same device. To do this, we first reset the router to factory defaults by pressing the factory reset button for a few seconds until the ACT LED starts flashing. Once the router is restarted, you can log into it using the default username and password admin. Now go to the System Maintenance Configuration Backup menu. Select Restore Configuration except the login password, then browse to the location of the backup file. Then click the Restore button. Then click the Restart button to reboot the router to accept the configuration file. Once the router reboots, you can log in using the default username and password admin, and all other settings will be restored. The second method to reset the admin password in a DrayTek device is to use Vigor ACS software. For this method to work, the device must already be managed by ACS. There are 3 options you can use here. These are Reset Password using the Maintenance option, Reconfigure the password by device configuration, and Reconfigure the password by the TR069 parameter. I won't go into detail here, but if you're interested, I'll leave a link in the description below to a previous video we made that goes through it. Damaged firmware is a common issue which can arise after attempting to upgrade the router firmware. This can be caused by the firewall in the PC used to perform the upgrade at blocking the firmware file transfer. When this occurs, the router will come up with a firmware damage message similar to this shown here. When the router is in this state, restarting it will cause it to become unresponsive. The solution here is to first disable the PC firewall and then use the firmware upgrade utility to install the firmware. That's if upgrading through the web GUI doesn't work. If the router does become unresponsive, you'll usually see 2 or 3 LEDs flashing in unison on the front panel on the router, or in some cases all the LEDs are on solid. Power cycling usually doesn't fix the issue. Routers this happens to are sometimes called bricked because that's essentially all they're good for in this state. Thankfully, DrayTek has a recovery procedure which usually gets it going again. You'll first need to put the router into TFTP mode. That involves first switching off the router, then switching it on again while pressing the factory reset button. When in TFTP mode, the router will default to 192.168.1.1 and the password will be admin. The computer will also need to be connected to the router LAN port, and you'll need to configure the PC with a static IP address. Once the LEDs start flashing, release the reset button and use the firmware upgrade utility to install the firmware. You'll have about 30 seconds to start installing the firmware before it times out. If that happens, you'll need to start over. Okay, let's see what that looks like in action. So first turn the router off, then using a pointed object, press and hold the reset button. While holding the reset button, switch the power on, wait until the LEDs start flashing together, and then release the reset button. The flashing sequence may vary between models. On this one, we just get a flashing activity light. Then open the firmware upgrade utility and enter the default router IP address 192.168.1.1. Browse to the firmware file and select it. Enter the default password, admin. Leave port and time at the default settings. Then open a command prompt and set a continuous ping to the router. You should see replies. Then click send. When the upgrade is complete, you'll get a message saying the router is active. Then you can open a web browser and go to the router web interface to check it worked. Okay, let's now look at debugging VoIP issues. DrayTek have a number of router models with built-in VoIP services, such as the Vigor 2865 VAC and the Vigor 2765 VAC. Some typical VoIP issues which can arise are failing to register with a SIP service provider, call dropouts, one-way communication, and unable to make or receive calls. This is a large topic, so today I'll just give an overview of what is involved in troubleshooting. There is more information in the knowledge base article shown here, which I'll link to in the description below. It helps to understand the SIP registration process when analysing VoIP debug logs to troubleshoot issues. There are two types of SIP registration processes shown here, and you'll see this information in the VoIP logs. To capture the VoIP debug logs, you'll need to go to the router CLI and run the command VoIP debug show MSG. It's recommended to first flush the debug log to make it easier to see the log for the current call you're monitoring. To do this, run the command VoIP debug flush. If SIP registration is successful, you should see the message SIP/2.0 200 OK in the debug log, as you can see in the red box in this image. If the debug logs do not find the cause, then the next step is to capture the data packets using Wireshark. Instructions on how to do this are in the knowledge base articles 5366 and 5735. Both the debug logs and the Wireshark data capture can be sent to DrayTek support for analysis to find the cause of the issue. Another issue you may come across is not being able to log into the router. Some steps you can take are check the physical connection, check the router IP address, clear the ARP cache on the computer, and specify the HTTP port. To check the current HTTP port setting, you can go to the router CLI and run the command mngt http port *?. Some settings might also be restricting access to the router. This includes DHCP server disabled, strict bind IP to MAC, LAN interface disabled, LAN access control, VLAN tag enabled, and WAN bridged by multi-PVC VLAN. Finally, check the LED status on the front of the router. It may indicate damaged firmware, and you'll need to follow the steps we discussed previously to recover it. One issue often reported to us is that people are unable to log into the VIGA 167. This router is supplied pre-configured with bridge mode enabled. As a result, its DHCP server is disabled, which can cause a problem for some PCs to log in. The VIGA 167 has the default IP address of 192.168.1.1, so you'll need to assign a static IP address to your PC to be in the same subnet. Let's go through that in a little more detail. First, you'll need to set up a static IP address on your PC. To do that, open Network and Internet Settings. Click on Network and Sharing Center. Click on the Ethernet connection. Go to Properties and select IPv4. Set up a static IP address in the same subnet as the router, for example 192.168.1.40. The default subnet mask of 255.255.255.0 will be fine, and the default gateway IP can be the router's IP address, 192.168.1.1. Then click OK to save. Then open a web browser and type 192.168.1.1 in the address bar and enter. The router's login prompt should appear, and the default username and password is admin and admin. OK. VPN troubleshooting. I won't delve into this one too much today as it's really a separate topic on its own, but we did run a couple of webinars some time ago which you can catch on our YouTube channel. I'll leave links to those below. I will discuss one issue that comes up often with LAN-to-LAN VPN tunnels, and that's when the VPN has been established okay, but there's no traffic flow. This is often due to routing issues, but there are some checks you can carry out. There's an application note you can refer to, which I'll link to below as well. The first item to check is if the remote PC you're trying to connect to allows ping. Often ping requests are blocked by the PC firewall. You can try some other hosts on the remote network or change the PC's firewall settings or just turn it off temporarily to rule it out. Next, you can check the routing tables in each router. If incorrect routes are shown, then check the setting for the remote network in the TCP/IP network settings section of the VPN profile. Another thing to check is the default gateway setting of the PC. It needs to point to the router IP address. To check if the default gateway is correct, you can run the traceroute command, and it should show the first hop to be the router IP address as shown in this diagram. Sometimes the router firewall policies can block traffic over the VPN. A quick check to verify if the firewall is causing the problem is to disable the default data filter. If this works, then you'll need to check the firewall rules to isolate which rule is causing the issue. An incorrectly configured load balance route policy can also send traffic to a different interface, so it's worthwhile reviewing the settings you have. Please note that if the IP subnet of both the local network and remote VPN networks are the same, it'll cause a conflict. To overcome this, you'll need to translate them to a virtual subnet before establishing the VPN. You can refer to the application notes shown here for detailed instructions on how to do this. You'll find that one linked below as well. Also note that IPsec with AH cannot pass through NAT, so if any routers are behind NAT, it's necessary to create the IPsec tunnel with ESP instead. Another issue that comes up sometimes is where network connection speeds are slow. This can be due to a number of causes. One of these is when the data plan is for a fixed upload and download speed. For example, 50 up and 50 down. In this case, the service provider requires the user to limit the speed of the outgoing traffic. Otherwise, if the outgoing rate is greater than the planned speed, they'll start dropping data packets. This will result in a degradation of the network connection, resulting in poor network performance. To fix this, you'll need to enable Ethernet WAN traffic shaping in the router by using the quality of service settings. More details are in the application notes shown down the bottom there. Another cause of slow Ethernet WAN connections for a new installation is when Ethernet WAN auto-negotiation doesn't work well with some NTU devices. NTU is an abbreviation for Network Termination Unit, which is similar to a modem and is what the service provider usually supplies to allow your router to connect to their network. When auto-negotiation doesn't work correctly, the router may detect that the device is set to 100 megabits per second full duplex, but in fact the NTU only runs at 100 megabits per second half duplex. This will cause large packet loss under heavy traffic conditions. To fix this, you'll need to manually adjust the speed and duplex of the WAN under the WAN General Setup menu as shown here. Network performance issues can also be caused by problems in the local area network. One of these is network congestion caused by all devices being placed on a flat network. This is where they all share a common connection to the router. For example, IP cameras usually generate a huge amount of traffic, and when they're combined with the PC network and IP phones, you might notice that PCs seem slow and phone voice quality is pretty ordinary. The solution here is to create multiple VLANs and place IP cameras in one network and IP phones in a separate network. You should see an immediate improvement in performance. LAN performance can also be degraded due to network flooding. This can be caused by a device with a faulty LAN adapter or even a broadcast storm caused by a PC infected with malware. To find the offending device, you can use the data flow monitor in the diagnostics menu in the router. Another issue some customers come across is WAN failover doesn't work as expected. For example, the primary WAN connection goes down, but the router doesn't fail over to the backup LTE connection. This is often caused by the selection of settings used for WAN connection detection. Most DrayTek routers have three options available for selection, which are ARP detect, ping detect, and always on. Later model routers now include strict ARP detect. The always on setting doesn't check if the WAN connection goes down and is only used for diagnostic purposes. Here's one problem that can occur when ARP detect is used. Here the router checks the connection status with the attached NTU or ISP connection. However, if there's an outage on the internet side of the connection, the router will not know that has happened since it's still getting an ARP response from the NTU. The result is that the router will never fail over to the backup connection. The solution here is to use ping detect mode instead. Here the router will send periodic ping requests to an internet site, which can be Google DNS or a gateway. If there's no reply to the ping from Google DNS, the router knows the WAN connection is offline and it will disconnect the primary line and activate the failover line. To configure ping detect, go to WAN Internet Access, select WAN connection detection as ping detect and enter the primary ping IP. You can also enter a secondary ping IP as a double check in case there's just something wrong with the primary ping IP. We can also set the ping interval and the number of retries before failover kicks in as well. Okay, so to summarise, we looked at some of the more common issues we come across from customers requesting assistance to troubleshoot. These included capture router syslog, unexpected router reboot, forgotten admin password recovery, damaged firmware, unresponsive router, debugging VoIP issues, unable to log into the router, that's the Vigor 167, VPN up but no traffic, network slow, and WAN failover not working as expected. Hopefully you'll find these troubleshooting tips helpful when you come across these and other similar issues. Okay, that's all for now, but please stay tuned. If you have any questions, we'll be available in the live chat on the right of your screen for the next 5 minutes. For more information about DrayTek products, please check out our website at www.draytek.com.au or send us an email to sales@draytek.com.au or give us a call on 02 9838 8899. Please like and subscribe below, and if you'd like a notification anytime we put up a new video, please select all from the subscribe drop-down menu as well. Thanks and bye for now.